Welcome back. In this module, we're going to learn how to differentiate the quotient of two functions using something called the quotient rule. In earlier modules, we looked at how it was possible, through the operations of composition and multiplication, to form a new function from two existing ones. Another method is to simply divide one function by the other, to form what is known as a quotient function. Observe the following examples. Just like how it's possible to differentiate a product function using the product rule, there exists a rule for quotient functions. If we call the numerator function u and the denominator function v, then the derivative of the quotient function u divided by v is equal to the function v times the derivative of the function u minus the function u times the derivative of the function v, and this is all divided by the function v squared. If you prefer to call the numerator and denominator functions f and g respectively, then the quotient rule can be stated as g times f dash minus f times g dash all over g squared. Let's do an example. Consider the function y equals to e to the x divided by the quadratic function x squared minus 1. Calling the numerator function u and the denominator function v, the quotient rule then states that the derivative dy dx of this quotient function is given by v times the derivative of u minus u times the derivative of v all over v squared. That is x squared minus 1 times the derivative of e to the x, which is just e to the x, minus e to the x times the derivative of x squared minus 1, which is just 2x. And this is all over v squared, that is x squared minus 1, all squared. And this gives us the following upon simplifying. Here's another example. Denoting the numerator function 2t by u and the denominator function 1 plus 2t cubed by v, the derivative dy dt is given by v, that is 1 plus 2t cubed, times the derivative of u, which is just 2, minus u itself, that is 2t, times the derivative of v, which is 6t squared. And this is all over the function v squared, that is 1 plus 2t cubed, all squared. And this gives us the following upon simplifying. Here's the final example. As usual, letting u be the numerator function and v be the denominator function, the derivative dy dx is given by v times the derivative of u minus u times the derivative of v, and this is all over v squared. Alright, time to pause the module and have a go at the following practice questions. And here are the answers.